each and every clock bit will go in a substantial way and it is not triggered at the same time. So that's why it is called as ripple counter. Now, as I told, the input which is considered is completely dependent on the select line. The second type of shift register is a PISO, which is none other than parallel input and serial output. Hello everyone, I welcome you all to the third session that's under Unit 4, that is under Digital Computer Organization subject. Yes, let me tell you, this is an updated subject with respect to SCP syllabus, which is the new syllabus which is being out by MYSURU University. Yes, we have completed almost all the units and this is the last session of this unit, that's Unit 4. So the Unit 4 is all about combinational and sequential logic circuits. My name is Deepa Kutnikar. I'm working as an assistant professor that's under Department of Computer Science, Vidhyaashram, Temple of Excellence, Mysuru. Let's move forward and understand, like in our last session, that is in previous session, what are the things that we have discussed. Yes, in our previous session, we did discuss regarding flip-flops, like we understood what is a flip-flop and what are the different types of flip-flop. And in order to overcome the drawback of each and every flip-flop, we learned the updated flip-flops, that's under flip-flop. And next we did discuss what is a decoder, and under that decoder we learned like what is a 3 to 8 decoder. Up next we did discussed encoders. Under encoder specifically we learned a octal to binary conversion. So this is all about our previous session, and in today's session that we will be discussing regarding counters. So we will be learning like what is a counter. We also will be learning a mux, that is nothing but a multiplexer. Then followed by we will be finally learning there is something called as shift register. Under that is SIPO, and one more is PISO. So what is this and what is the full form of these things will all be discussed in our upcoming slides. So let's start the session with understanding multiplexer. Yes, the multiplexer which is there in your syllabus is 4:1 multiplexer. What is this 4:1? Yes, it is nothing but we are defining input and output bits. So we will be having 4 inputs and 1 output bit. That is nothing but a multiplexer. Also, multiplexer is also called as a type of combinational logic circuit where we will be defining various inputs and single output. The inputs are completely dependent on 2 of the control signals, that is also called as select lines. So let me explain it with respect to this block diagram. Here we can see it is a 4:1 multiplexer. This multiplexer is known as many to one. Why it is many to one? Because we'll be having many inputs, or we can say multiple inputs and single output. That's why it is called as many to one, or simply it is called as multiplexer. These are the 4 input bits and a single output. These are the control signals which are called as select lines. Clear? Now, as I told, the input which is considered is completely dependent on the select line. So let's see how is it dependent. So in order to check that, let's have a look with respect to table. As we can see, we are dealing with 2 of the select line, that is S1 and S2. As we are having 2 inputs, we will be dealing with 4 different combinations, that is 0, 0, 1, 1 followed by 0, 1, 0, 1. With respect to output, when both the select lines are 0, then which input line goes? That is the 0th input line, D0 will goes high. Then if I'm having S1 1 and S2 0, at that time my D1 bit will be enabled. Clear? What about the other bits? Yes, other bits will be 0 or in a level low. We can say in a state low. Now let's see, this is the next input, that is 1 and 0. For that, the bit which is high is D2. Similarly, when both the select lines are high, at that time the input which goes is a D3. So this is a vector table of a multiplexer. Here we have defined something, that is again the input. So we are having 4 inputs, that is D0 to D3. Selection inputs, that is S0 to S1. Those are 2 and output 1. So it is important to describe what are the things that is defined or used with respect to block diagram. This is about a multiplexer. Let's head up with understanding the counter. Yes, let's head up with counter, that is a 3-bit binary ripple counter. Great. First, and let's understand each and every words. Okay, starting with counter. Counters are nothing but a basic block of digital electronic circuit where it is used to count the events. Clear? Up next, let's see what is a ripple counter. But here we have some more thing to explain, that is, it is a part of sequential circuit that goes through the predefined sequence of states which it is completely dependent on the clock pulses. So this is a simple counter. Now next, let's see what is a 3-bit binary ripple counter. 3 bits. So here we will be using 3 different stages in order to design a 3-bit ripple counter. We will be using either a T flip-flop or JK flip-flop in order to design a 3-bit counters. And also it is called as ripple counter. Why it is called as ripple counter is the clock pulses ripples through the flip-flops which is not at all triggered at the same time. So each and every clock bit will go in a substantial way and it is not triggered at the same time. So that's why it is called as ripple counter. Move forward and understand the shift registers. Yes, already we know, like we have a basic idea of register, like register is used to store something, right? Here we are studying shift register. Shift register is also a very crucial part of digital circuits, and here we will be using multiple levels. Even it is a type of sequential logic circuit that is completely made up of flip-flops. Yes, the shift registers are nothing but a cascade of flip-flops where you can store the binary bits and even it is shifted to next stage as well. So that's why the name shift register, where you can store and you can shift that stored data or some other data to the next level too. Yes, that's possible. So that's why it is called as a shift register. The main thing over here to note is it is completely dependent on a clock signal, okay, where it ensures the synchronous shifting of the stored data or a input bit. And the main point to note here is it will be able to store only a bit of data and the same data or other data can be forwarded to the next level or the next stage. Also, it forms a basic building block of D flip-flops. As one of the clock pulse passes, it transfers the bit that is stored in one of a flip-flop to other stage. This is all about a shift register. Up next, we have multiple types under this, where let's start learning with a serial input and a parallel output shift register. So it is very easy and simple. Let's see what it is. Yes, it is SIPO. It is serial input and parallel output. As the name itself says, the input will be considered serially, that is one by one. After considering or collecting the input bits, then at the output, not only one output will be sent, all the outputs will be sent at the same time, that is parallelly. So serial in and parallel out. This is nothing but a SIPO shift register. And we can also note here, even it is dependent on a clock signal. Up next, we have a simple working. Let's see the working of a SIPO by using a simple block diagram. Yes, this block diagram is constructed by using a D flip-flop, and under D flip-flop, we will be having a data input line, that is a input, and as usual, as it is a flip-flop, a clock will be there. Along with that, you will be having the output, that is Q. Alright, we are having 4 stages here, and let's start with the input. The data is fed to the first stage of a D flip-flop, and whenever a clock goes high, at that time the data which is stored, or we can say the output of the first stage, will be forwarded to the next level. Okay, here when it is done, whenever the clock pulse changes. All right, up next what happens? Again the same thing, the clock pulse will be changed and we can see here the output is inputted to the next level. Here we can see there is a serial input. So at the time only one input is provided, and we can check here the output of first stage is fed as the input to the second stage. Clear? And once this is done, and again we have to wait for the clock pulse. So here input is given, output is generated. Up next, what is it? The output is fed out up, and the output has to wait for the next clock pulse in order to send it or shift it to the next level, that is for the third level. All right, clock pulse changed, and the second stage output will be provided as an input for third stage. Clear? Here the process happens and you'll be getting the output. So that output is sent out. Up next, what is it? Again, we have to wait for a clock pulse change. Once the clock pulse is changed for that level, we have to send the output of third level as an input to the fourth level. And again, the process remains the same thing. All the operations will be done. Up next, the output will be sent out, and here there is no other stage, correct? So there is no need to feed the output to next level. So these are the complete 4 stages, and this is how a SIPO work. And the main thing to note here is the input are serially provided for each and every stage, but output are provided all together. It can send one by one, or it can directly send all the outputs at the same time. That is why it is called as parallel output. So this is all about a SIPO. Now next, the second type of shift register is a PISO, which is none other than parallel input and serial output. For this, we will be calling it as a complete inverted form of SIPO, because in SIPO, we were sending only one input at a time and we were collecting all the 4 outputs at one time, correct? Here it's completely opposite of that. That is, we will be sending all the multiple inputs at the same time, which is also called as parallel input is fed, and we will be getting output serially. So that is parallel in and serial out. Moving up with working, we can consider here the 2 modes. One is a load mode and second is a shift mode. Yes, absolutely. Under load mode, what happens is all the inputs will be loaded and sent simultaneously to the input. That is, parallel it is sent. Once it is sent parallelly, what happens next? The flip-flop switches to the shift mode. And with each clock pulse, the stored data will be shifted to the next levels. So this is the working conditions. So let's see it with an example of a block diagram. Here we can observe we are having multiple inputs, right? So yes, we are having one of the input which is inverted, and we are having the same input followed by the multiple gates input. Great. So those inputs are fed simultaneously when it is fed under load. Okay, under load mode. Okay, it is done when it has to start working. Yes, it depends on our clock. Again, before going with the clock, let me say we are again dealing with 3 of the D flip-flops, which is nothing but a data flip-flop, where we'll be having one input, that is D, and one output Q, followed by a control clock signal. Whenever this clock signal goes high, at that time we will be representing one more mode, which is called as a shift mode. Okay, under the shift mode, the output is fed, and up next the second flip-flop starts working. Similarly, once it is done with the operation, it has to wait to the clock signal. Once it is done, again it will be getting an output which is B, which will be sent to the next part, that is a flip-flop 3. Again, we have to change for the change of clock pulse, followed by the input will be provided to the clock pulse. So it is shifted one pulse by one, that is one bit by one. So that's why it is called as a shift register. Which type of shift register? It is a parallel in and serial out. At output, you can note here, you'll be getting only one output, that is a serial output. Clear? So this is all about a parallel input and serial output. Great. So this was with respect to today's session, and we are completed with unit 4. Yes, I would like to wish you all the very best for your exams, as we have completed with our complete DCO syllabus, and wish you all the best and all the good lucks for your exams. Do well, study well, and get back to the sessions, understand them, and try to score very good. All the very best. Thank you.